This is the Assalamu alaikum. Okay, class. First, let's just understand a few things before we go on to complex loci. Let's make two complex numbers. One of them is ZA, which is 2 plus iota, and the other one is ZB, which is 3 plus 2 iota. And I'm calling another new complex number ZC, which is technically ZB minus ZA. Okay? Okay. So now if I ask you the modulus of ZB minus ZA, can you tell me the mod of ZB minus ZA? Figure it out. First, you'll need to figure out the complex number ZB minus ZA. What will be ZB minus ZA? What will be the complex number ZC, which is ZB minus ZA? 1 plus iota hoga. 1 plus iota hoga. And then once you find the modulus, that is under root 2. So once you find the modulus of ZB minus ZA, and you plot it on an Argand diagram, you will see that it is basically the distance between the 2 points. Or I can say that it is the distance of ZB from ZA. Is this clear? So that is what ZB minus ZA mod means. So ZB minus ZA ka mod means distance of ZB from ZA. Similarly, if I ask you the argument of ZB minus ZA, now remember ZB minus ZA, we have just given it a new name, which is ZC. You can figure it out, that is 1 plus iota. If you find the argument of ZB minus ZA, that is the angle between the line and the horizontal. Which particular line? Again, the line between ZB minus ZA and the horizontal, the angle between this line and the horizontal. Is this clear, class? So if I make a horizontal line over here and calculate the angle that this line is making with the horizontal, this is the argument of ZB minus ZA. Is this clear? Again, you can verify it once you take the complex number, once you make a new complex number, which is ZC, ZB minus ZA. That will be 1 plus iota. And if I ask you to find the argument of 1 plus iota, what will be that? It will be this angle. So isn't it the same angle? So yeah, so technically just understand these two things. These two are the basic points to understand. That if I ask you mod of ZB minus ZA, you're trying to tell me that it is the distance of ZB from ZA. And if I ask you the argument of ZB minus ZA, that is the angle between the line. Which line? The line that is joining ZB with ZA from the horizontal. So the angle between the horizontal and the line is called argument of ZB minus ZA. Now let's try to put it into perspective. If I ask you mod of Z is equal to 1, again, what am I trying to say? Z minus 0. In other words, the distance of Z from the origin is 1. Now, how will you show it on an Argand diagram? What will you draw and what is the locus? Locus is the possible location. So what is the drawing that you will be making? You will say, sir, let's make a circle with center 0, 0 and radius 1. And where will Z lie? Z will lie anywhere on the circumference of the circle. Why? Because the only thing we know about Z is that its distance from the origin is 1. Is this right? Similarly, if I don't know the complex number Z and I know that Z minus 4 plus 2 iota is 2. Now, what is this trying to imply? It's trying to tell me that the distance of Z from 4 plus 2 iota is 2. That is all that I know about Z. Now, what will I make? I'll make this the center of my circle. I'll make a circle with radius 2. That is just the drawing that we'll be doing. But what will we say about the locus or the possible location of Z? Again, we'll say that Z will lie on the circumference of the circle. Is this clear, class? Okay, now if I ask you Z minus, the mod of Z minus 5 is equal to 2. What does that mean? Again, I don't know what Z is, where the complex number Z lies. So what will I say? That the distance of z from 5, now if I'm saying just 5, that means a real value of 5 is 2. Again, understand the drawing and the locus. Both are two different things. So you'll still be drawing a circle. The center will be 5, 0. The radius is 2, and you will say z will lie on the circumference of the circle because its distance from 5 is always 2. Okay, class. Now what about z plus 2 iota is 1 again? Circle. What will be the center? If I'm saying it's z plus 2 iota, remember. Can I write it as z minus 2 iota? So the center will be 0, comma, -2 on the Argand diagram and 0, comma, -2. And the radius will be 1, and z will again lie on the circumference of the circle. Again, same thing. What will be the center for this one? -3 and 5 will be the center, and the radius will be 3. Is this clear, class? And again, z will lie on the circumference. Now, what about this? If I say mod of z is greater than 2, what am I trying to tell you about z? Again, I don't know where the complex number z is, but one thing I know for sure, that its distance from the origin is greater than 2, right? So if the distance from the origin is greater than 2, I'll still make a circle, center 0, 0, and radius 2. But now what will be the possible location of z? What will be the possible location of z? Yes, it will lie anywhere outside the circumference of the circle. Is this clear? Okay, similarly, if I give you this, again, what am I trying to imply here? I'm trying to say that the distance of z from 6 plus iota. Now, the distance of z from 6 plus iota, how? I can just take the negative sign common, and I'll be left with 6 plus iota. Just like in this case, the one that we have done, we can take a negative sign common and write it as z minus in bracket 6 plus iota. So I'm trying to imply that the distance of z from 6 plus iota is 1 or lesser than 1. So we'll say again, we'll be drawing a circle. Center will be 6 plus iota and the radius will be 1. Now, where will z lie? Z will lie on the circumference or inside the circumference. Now, what about this? What is this trying to imply? Again, just think of them individually. What is this trying to tell? This is trying to tell me that the distance of z from 3 iota, right, is equal to the distance of z from -2. Now, if I'm trying to find the distance from 2 points, we have done it in O-level loci as well. If I tell you, bete, the distance of z from 3 iota or the distance of z from -2 is the same. So where will z lie? It will lie anywhere in the middle of 3 iota and -2. Yes. And if I make a perpendicular bisector between these 2 points, z will lie anywhere on the perpendicular bisector. So understand the basic 2 concepts of loci. Once you understand that, you'll be able to figure out all the possible drawings and the possible locus. Understand this thing individually. What is this trying to tell you? The distance of z from 3 iota, the distance of z from -2. So the distance from both the points is the same. So what do? I draw a perpendicular bisector between both the points. And where does my z lie? It lies anywhere on the perpendicular bisector. Is this clear, bacho? Is this clear? What about this? What is this trying to tell you? Distance of z from -2 plus 3 iota is the same as the distance of z from the origin. So, origin, Again, what is this trying? I still don't know where Z is, but I'm trying to tell you that the distance of Z from -2 plus 3 iota is the same as the distance of Z from the origin. You know that Z is equidistant from 2 points. What 2 points? -2 plus 3 iota and origin. So if it is equidistant from 2 points, you'll be drawing a perpendicular bisector between origin and -2 plus 3 iota. And again, Z will lie on the perpendicular bisector. Is this clear, class? Similarly, if I tell you this, now what is this trying to tell you? The distance of Z from -2 minus iota is greater than the distance of Z from 3 minus 2 iota. Again, the question or the statement concerns you with the distance between 2 points. So if you want to find the distance between 2 points, you still be making a perpendicular bisector. But where will you say your Z lies? Its distance from -2 negative iota is greater than its distance from 3 plus 2 iota. I'll show it to you. Let's understand both the points. -2, -1, and 3 and -2. Okay, now let's make -3 and -2, -1, 3, -2. Okay, class. So this is one point. And what is the other point? -3 and 2. Or is it vice versa? 3 and -2. Now these are the 2 points. And what is this statement telling me? So 3 and -2 and -2 and -1. So this statement is telling me that the distance of Z from this point, this distance is greater than that from this point, right? So if I draw a perpendicular bisector between, can you people see the screen? Yes, class? So this is a perpendicular bisector. Now, if Z lies on the perpendicular bisector, I'll say that it is equidistant from the 2 points. But if it lies on the right, its distance from this point is lesser as compared to its distance from this point. So on the right means once we draw it on the Argand diagram, only then we'll be able to see on the right. But even looking at this and relating it to the knowledge that we have, this is the point that lies on the right. यहाँ पे x ज़्यादा positive है, so this is the point that lies on the right. So the distance from this point is okay, class. Is this clear? Is this clear? So understand the entire thing. Okay, now what about this? Argument of Z minus 2 plus 2 iota is equals to pi by 4. Now, if you take a point 2 plus 2 iota and you draw a half line, so what will you say? Okay, 2 plus 2 iota is a point. 2 plus 2 iota. Okay, now if you take this and you draw a half line and you measure its angle from the horizon, This is what we call argument. We just discussed it. And where will z lie? That is what we need to understand. I'm telling you argument of z minus 2 plus 2 iota is pi upon 4. So from this point, if I make a half line of pi by 4, pi upon 4, z will lie anywhere on that line. Is this clear, class? We'll do more questions and then this will be clear. So don't worry about that. Okay. Okay, class. Some common tips that I would like to suggest with this is whenever you make an Argand diagram, use same scale for x and y axis so that you get proper shapes. And I'll suggest you, if it concerns of so many marks, use the proper scale and a proper compass and not just to sketch it. It's to sketch it, but do not be extremely accurate, but try to get your circles and everything right. On a sketch of an Argand diagram, shade the region whose points represent complex numbers z satisfying the inequalities. So now what is the first one trying to tell me? The distance of z from 2 iota is lesser than or equal to the distance of z from 1 plus iota. So the distance of z from 2 iota is lesser than or equal to the distance of z from 1 plus iota. What will you be drawing? You'll draw a perpendicular bisector between 2 iota and 1 plus iota. And z will be closer to the 2 iota point, right? Because its distance from 2 iota is lesser than that, its distance from 1 plus iota. Now, what about the next one? What is the next one suggesting? Distance of z from 2 plus iota is lesser than or equal to 2. So what do you do here? 2 plus iota से distance 2 या उससे कम है. Now it has given you a numerical value. Now it is not comparing distances. It has given you a numerical value. 2 plus iota से 2 units या उससे कम है. So 2 plus iota will become your center. And you'll draw a circle of radius 2 units. And you'll say that z lies anywhere on the circumference or inside the circle. Because they have given you a numerical value, you'll always be drawing a circle because it's telling you a particular distance. And when it compares two distances, you'll be making a perpendicular bisector. So again, once you are done with this, you make a perpendicular bisector between 2 iota and 1 plus iota. This will be your perpendicular bisector. 2 plus iota will be your center. You will make a circle of radius 2, 2 units up, 2 units down, 2 units right, 2 units left, and you can sketch a circle. And you know that z will lie somewhere on the circumference or inside the circle. And its distance from 2 iota, z will be lying closer to 2 iota. So if I make the perpendicular bisector, I have to keep z closer to 2 iota. So as per this diagram, it has to be on the left. So this is the region where z can exist. Is this clear? Okay, class. Now let's try to attempt this one. Okay, class. So once we have figured out the value of u, it is negative under root 3 plus iota. Now we come to the loci of this question. The question says that mod of z is less than 2. That means its distance from the origin must be less than 2. So I take center, origin as the center, draw a circle of radius 2. And I'll try to draw this a dotted circle. A dashed lines, not solid circle, and I'll say that z lies anywhere inside the circle. And what about this? Distance of z from u is lesser than distance of z from the origin. So we'll be making a perpendicular bisector between origin and U. Now, where will Z lie? Has to be inside the circle, and its distance from U is lesser. So again, on the left of this, so this is the region where we will find Z. This is the region that you eventually shade. Your line will also be dashed because the line itself is not included, and your circumference will also be dashed because the circumference is also not included. Is this clear? Because there is no equal to sign in it. Is this clear, bachon? So once you make a solid one, you just erase it from the middle and it will automatically be dashed. Is this clear, bete? How do you draw a perpendicular bisector? You take a compass, open it around more than half, make an arc above and below, keep it on the other point, make same arcs. When the arcs join together, you just draw a line, and that is the perpendicular bisector. Is this clear, class? Okay, so the question has told us that U is -1 plus under root 7 iota. And then now let's focus on the loci part of this question. On an Argand diagram, sketch the locus of points representing complex number Z, satisfying the equation mod of Z minus U is equal to 2. So what will you do? The distance of Z from U is 2. So U will be your center. Make a circle, U as center, U is -1 plus under root 7 iota. Find the decimal value of under root 7 so that you make a relatively accurate sketch. And Z will lie anywhere on the circumference of the circle. Right? You make a circle and don't shade it in the middle. Just as seen in the diagram, just make a circle and it shouldn't be filled from inside. So now, determine the greatest value of argument. Remember, Z can be anywhere on the... Okay, now the question says the greatest value of the argument of Z for a point on this locus. Give your answer in radians. So Z can be anywhere on the circumference of this locus. Okay, now I'm moving with Z. Tell me what is the greatest argument that I can get. If Z is at this point, the argument is you'll make a line from the origin and then you'll measure the angle from the positive x-axis, right? So you keep on moving down, 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 and the least of the least point, if Z is on this point, so this is the point where the argument of Z is the greatest. Now, can you find that angle? Do it. Okay. Yeah, so you have this as a right angle triangle. What is the length of the radius? It is 2. So what is the length of the modulus of U? What is the length of the modulus of U? No, the length of it is 2 root 2. So once you have this as 2 root 2 and this is 2, you'll find that this will also be 2. So this is an isosceles right angle triangle. So this angle is pi by 4. You can find this small angle between the mod of U and the y-axis and add pi by 2 to it, and you get the argument of Z. Tan laga lo. You can apply tan. The opposite side is 1 and the adjacent side is under root 7. So you find this small angle with the y-axis pi by 2 and this is pi by 4, which is 45 degrees, because this is an isosceles right angle triangle. Kaise pata chala?